Question 2, Part C. Solve the equation cos 2 theta equals sine theta for theta greater than or equal to 0 and less than or equal to 2 pi. The strategy is to form a reducible quadratic equation using a single type of trigonometric function. So let's start with the original equation. Cos 2 theta equals sine theta. Now cos 2 theta can be expressed in terms of sine theta. So cos 2 theta can be written as 1 minus 2 times sine squared theta, and that's equal to sine theta. Now multiplying both sides of the equation by -1, we have 2 sine squared theta minus 1 is equal to negative sine theta. And the only reason why I did that is so that the term involving sine squared theta is positive. Now moving everything over to the left-hand side, we form the reducible quadratic equation 2 sine squared theta plus sine theta minus 1 equals 0. Now if we let u equal sine theta, just to simplify the quadratic equation somewhat, we could write it in terms of u. We get 2u squared plus u minus 1 equals 0. Now this is a non-monic quadratic equation, but it does factorize nicely, and we get 2u minus 1 in brackets times u plus 1 in brackets equals 0. So we get the solution in terms of u equals -1 or u equals half or 1 over 2. So this gives rise to two cases. Now we know that u is equal to sine theta and we want the solution in terms of theta. So let's consider case 1. Case 1, u equals -1, which implies that sine theta equals -1. So solving for theta, we get theta is equal to 3 pi over 2 or 270 degrees. And in case 2, sine theta is equal to 1 over 2. Now that's a positive ratio, which means that the angle theta can either be in quadrant 1 or quadrant 2. So consider the quadrant 1 angle. We get theta is equal to pi over 6 or 30 degrees. The quadrant 2 angle is the supplement of pi over 6, which is 5 pi over 6. So putting that all together, we get theta is equal to pi over 6, 5 pi over 6, or 3 pi over 2.